All right, welcome to the channel. And here I'll be talking about solids of revolution as we have looked at the polyhedra solids. And at the beginning of this topic, we talk about the nature of solid, where I said that a solid has three dimensions: the length, the breadth, and the thickness or the height. Okay, so then I talked there that we have two types of solids, or solids are uh, grouped into two, and there we talk about polyhedral solids, and then we talk about solids of revolution. So the first video focused on polyhedra, and we talk about seven of them. So here we are looking at solids of revolution, as I said, and the first among them is cylinder. And what you need to know about cylinder are what I put here. And the first one is that a right circular cylinder is a solid generated by the revolution of a rectangle about one of its sides, which remains fixed. Okay, so just like you have a cardboard and you fold it to form a cylindrical surface. And another thing about a cylinder is that it has two equal circular bases. As you can see here, this is one circular end and this is the other circular end. So it has two circular bases. Then we also have that the line joining the centers of the bases is the axis and it is perpendicular to the bases. So this is the axis, that is the line that connects the two circular ends together. So it is perpendicular to each of the base. That means it is at a right angle to each of the bases. So these are the information that you need to have about a cylinder. Then let's look at a cone. Let's look at cone. So for cone, we have this information to know about a cone. And a cone is another type of solid of revolution. And as we have it, that a right circular cone is solid generated by the revolution of a right-angled triangle about one of its perpendicular sides, which is fixed. So then you also have that that's one circular base. Its axis join the apex with the center of the base to which it is perpendicular. So as we have here, it has one circular base. This is the circular base, and there is an axis that connect the apex and the base together. So don't forget that the axis is at the right angle to the base. Then we also have that the straight line drawn from the apex to the circumference of the base circle are all equal, and they are called generators of the cone. So we are talking about these straight lines, and as you can see, that is indicated here what we call generators. So the straight line that we draw from the apex to the circumference of the base is known as generator. So we have them here. So on this diagram, we have about four generators. So, and then the length of generator is the slant height of the cone. So this line, the length of generator is the slant height of the cone, as can be asked in mathematics that we should find the slant height of a cone. So as you can see here, the length of generator, as said here, is the slant height of the generator of the cone. Sorry. Okay. So then another solid of revolution is a sphere. And one thing about sphere, we have this information about sphere. A sphere is a solid that is generated by the revolution of a semicircle about its diameter as the axis. Then we also have that the midpoint of the diameter is the center of the sphere. All points on the surface of the sphere are equidistant from its center. So that's what we have about the sphere as a solid of revolution. Then, I said note here, oblique cylinders and cones have the axis inclined to their bases. And I've said that even under polyhedra. So I talked about the oblique cylinder and also the right cylinder. So when the axis is inclined at an angle to the base, we call it oblique cylinder or oblique cone, or it can be oblique prism or oblique pyramid. So then we also have a right cylinder, a right cone. That means the axis is at a right angle to the base. So that's the difference between an oblique cylinder or prism or pyramid, an oblique cylinder or prism or pyramid or cone. Okay. Then we also have this information about frustum and truncated solid. Frustum and truncated solid. So the difference between frustum and truncated solid, let's talk about it here. So we have that when a pyramid or a cone is cut by a plane parallel to its base, and thus removing the top portion, the remaining portion is called its frustum. So when for us to get a frustum, as we see here, these two solids are frustums. So this is a frustum of pyramid, while this is a frustum of cone. So if you look at these solids very well, if you look at this frustum very well, so the cutting plane, it cuts the upper part of them, and then the cutting plane is parallel to the base. Okay, it's parallel to the base. That's why we have this surface here being in a straight form, not bent. Okay, so that makes each of these frustum, each of this one, it makes it a frustum. But when we talk about a truncated solid, as we have read that when a solid is cut by a plane that is inclined to the base, it is said to be truncated. So supposing it is cut like this, the cutting plane goes like this, and make the surface to look slanting. So it's what we get is a truncated solid. What we get is a truncated solid, but in this case, we have the cutting plane. It is parallel to the base of each of this solid. So it makes this remaining part to be frustum, not a truncated solid. So let's take note of that, the difference between a frustum and a truncated solid. So this is the information that I have about a solid of revolution, as I've talked about polyhedra. So thank you and God bless you.